Good morning, students.
Good morning, ma'am.
So, today we are going to start with new unit that is Verilog model for combinational logic design. But before that, I would like to know about the feedback of first two units. Whether you understood all, or is there any doubt about that two units?
No, ma'am. Understood.
Okay. I would like to know from others also. 43 students have joined this meeting, so I would like to know from
Understand, madam.
Okay. Silicious, do you have any doubt? This is fine.
No.
Hello? You have any doubt again telling us what you can call me. That
Excuse me,
also
ma'am. मॅम
yes.
तुमचा आवाज खूप ब्रेक होतोय.
Wait a minute. Check it now. Is it clear now?
Yes, ma'am.
Hello? Okay. So, uh, start new unit. But again, one thing that I would like to tell you, whenever you are texting in a chat box, okay, so regarding your attendance, have a same format. All of you have a same format like B dash your roll number, okay, without any space. So someone has like a format like B underscore then roll number. Someone has writes name first and then after that their roll number. So your user ID, whatever name that you are having for Google Meet, that you modify it as a your division, then dash and your roll number. Okay, so that it will be easier to mark your attendance because sometimes uh, it may any number may get missed. So you have all of you have the same format so that it will be easier for all the faculties to mark your attendance. Okay, so change this format whatever you have for your user id तुमचा जो काही गुगल मीट साठीचा आयडी आहे त्याच्यामध्ये चेंज करा. ओके, आणि तो बी डॅश सगळ्यांनी लक्षात ठेवायचं पहिल्यांदा तुमची डिव्हिजन त्याच्यानंतर डॅश आणि तुमचा रोल नंबर या फॉर्मॅटमध्ये असू देत. ओके, आणखीन एक म्हणजे बरेच जण मीट जॉईन करतात आणि थोड्या वेळानंतर लेफ्ट करतात. ओके, आय हॅव रेकॉर्ड ऑफ ऑल द स्टुडंट्स वेन दे गेट जॉईन टू दिस मीटिंग अँड वेन दे लेफ्ट. Okay, so don't do like this, otherwise henceforth your attendance will not be marked. So listen carefully whatever is happening here so that it will be easy to understand the concepts when you rejoin college. Okay, so now today we are going to start with the new unit that is Verilog module for combinational logic design. Okay, So the content in this unit, that is, first we are going to discuss about introduction to Verilog HDL, then structure of Verilog model. After that, types of models, then data types, operators, then HDL implementation of half adder, then full adder, half subtractor, full subtractor, encoder, decoder, multiplexer, demultiplexer, and comparator. Okay. So that means first of all we will see concept.
मॅम ऐकू येत नाहीये नीट.
Hello. Hello. Are you getting now? Hello. Hello. ऐकायला येतंय का क्लिअर?
येस मॅम. येस मॅम येते.
Am I audible clearly?
नाही
Others,
मॅम.
please reply. Okay. Okay. So please be in the range. तुझ्या नेटवर्क मध्ये तुझ्या प्रॉब्लेम असेल मग जर काही लोकांना
मॅम
ऐकायला येत
तुमचा
असेल.
आवाज ब्रेक होतोय.
I have network but ते माझ I am in range. So तुम्ही तुमच्याकडून जरासं बघा की तुमच्या नेटवर्कला काही प्रॉब्लेम नाहीये ना. Okay. Am I audible to all?
येस मॅम.
Yes.
Okay. So let us continue. So as I discussed, so in a first part we are going to discuss about concepts regarding Verilog HDL, and after that we are going to see how to write code using Verilog for different circuits. Now all these circuits that we have discussed in a second unit, that is the VHDL model for combinational as well as sequential circuits. Okay. So now that means what is that circuit that you know? Actually, all these circuits that you have studied earlier, but just I have revised that part little bit in this second unit. Okay. So now there we have written VHDL code for all these circuits. Now we are going to write Verilog code for all these circuits. Now here we are just going to consider combinational circuits. We are not going to go for the sequential circuits. So we are going to just limit our discussion till adder circuitry, then subtractor, encoder, decoder, multiplexer, demultiplexer, and comparator. Only these circuits that we are going to discuss in this unit. Okay. And then books for this topic, that is Digital System Design Using Verilog by Charles Roth, which is by Sindesh Publication. Okay. So you can easily get PDF of this on internet, but I hope I have shared this in a Google Sheet. I'll check it, otherwise I will share it today. Okay. So that book copy is available with me, so I will share this. Again, another book, that is a HDL Programming, VHDL and Verilog by Najem Botras. So that is also another book that is to be referred for this unit. Okay. So these two books today I am going to share with you if it is not available in the sheet that is shared with you. Okay. Yesterday I have shared notes of second unit. Okay. Now you will find that are of 45 pages. So someone may think that array 45 pages lahache ka. Okay. So you can see that actually our topic was related to VHDL model of combinational and sequential circuits. So we have discussed that theory part, and after that we have VHDL model. Okay. So you can those who are clearly understood what is there in that circuit, they can skip theory part of this circuit. You can just write a VHDL code. Okay. But otherwise, those who want to understand, let us clear more about this concept, so they can write theory part also. But otherwise, you can skip that. part. Okay. So this is from my side. तुम्हाला जे काही convenient असेल ते तुम्ही करू शकता. Okay. But all the VHDL
एक्सक्यूज
code
मी
that
मॅम.
should be there in your. Yes.
मॅम क्लासमध्येच लिहून घेतले असतील
Yes.
तर सेकंड चॅप्टर कम्प्लीट आहे. मग
Okay.
म्हण
ठीक आहे, काही प्रॉब्लेम नाहीये मग तर. घेतलंय ना सगळ्यांनी लिहून, मग काहीच प्रॉब्लेम नाही. ज्यांनी नसेल घेतलं त्यांच्यासाठी आहे. ओके. सिन्सिअर स्टुडंट्सना काहीच प्रॉब्लेम नाहीये. सिन्सिअर अँड डू इट सिन्सिअरली. ओके. आता तुम्ही हे जर आत्ताच लिहून घेत असाल तर काहीच प्रॉब्लेम नाहीये तुम्हाला, आणि हे समजायला पण सोपं जाईल. ओके. सो डू इट हिअर ओनली सो दॅट इट विल बी इझियर. Okay. Again, I have shared assignment questions with you. So write these assignments also. You can write it on any pages as I said earlier. Okay. So this is about the syllabus content of this third unit. Now let us discuss about the title of this chapter. Now what this title suggests, in this unit we are going to have the idea about how to write Verilog modules for various combinational circuits, and that is why the title of this topic, that is Verilog modules for combinational logic design. But before that, now we are going to learn about Verilog HDL, so that will be present in this unit. Then what is the central idea behind this chapter?
एक्सक्यूज मी मॅम.
So the first is that, yes.
मॅम आधीची स्लाइड एक
Yes.
मिनिट हे करता का?
Okay, yes, it is there. Okay, you can write down this. So write down this about title of chapter. So write.
कम्प्लीटेड मॅम.
Okay. So the next is about the central idea of this chapter. Okay. The first is that this chapter provides knowledge about Verilog HDL. Okay. So as we have learned one HDL, that is the VHDL that we have learned. Now we are going for the another HDL language, that is a Verilog. Also this chapter provides knowledge of how to write. Okay. Sorry, this should be Verilog model for different circuits. Okay. So that is will be there, and also this chapter introduces programming skills using Verilog. So here it should be Verilog. This chapter provides knowledge about Verilog HDL. So write down this central idea of this chapter. This chapter provides knowledge about Verilog HDL. Then this chapter provides knowledge of how to write Verilog module how to write Verilog model for different circuits. And the last one, this chapter introduces this chapter introduces programming skills programming skills using Verilog. Using Verilog. Finished?
1 minute, ma'am. Yes, ma'am. Completed.
Then the next is importance of this chapter. As I earlier said, that this unit that introduces basics of Verilog HDL. So that is the important. In a industry, Verilog is the preferred language for hardware description. So that is why this chapter is important for you people. Okay, those who want to go for the core industries or those who want to go in VLSI, so learn VLSI. So for them, this chapter is very important. So this chapter introduces uh, Verilog module for different combinational circuits, and that is why this chapter is important as it will help to design VLSI systems using Verilog. I hope you have completed this.
Yes, ma'am. Completed.
Okay. And then we will see chapter outcome. So at the end of this chapter, you will be able to explain basics of Verilog programming. So that is the first outcome that you will get. Okay. So as we are going to discuss about various concepts regarding Verilog programming. So you will be able to explain that thing. And another thing that you will be able to write Verilog module for combinational circuits like adder, subtractor, then encoder, decoder, multiplexer, demultiplexer, and comparator. Okay, so that is the one more outcome that you will get. So write down this.
Completed, ma'am.
So now let us discuss about Verilog. Okay. So first tell me what is mean by HDL?
Hardware descriptive language.
Hardware description language. Okay, so that is the long form of HDL. So in the earlier units we have discussed about VHDL. So what is long form of VHDL?
VHSIC, hardware descriptive language.
Basic, that is a VHSIC, very high speed integrated circuit hardware description language. Okay, so that we have studied earlier. Now we are going for the another HDL, that is Verilog. So this Verilog was developed by Gateway Design Automation as a proprietary language for logic simulation in 1984. Gateway was acquired by Cadence in 1989, and then there was again advancement in this software, and then Verilog was made as an open standard in 1990 under the control of Open Verilog International, that is a OVI. So here actually this language that becomes open standard in 1990, and then this standard become as a IEEE standard in 1995. Okay, so it is the IEEE STD, that is a standard 1364. So as you know, VHDL is the IEEE standard 1164, and this is IEEE standard 1364. Okay, and it was again updated in 2001, and after that there was updation in 2005. Okay, so this is about the history of Verilog language. Okay, now what is Verilog? Verilog is a hardware description language, that is a HDL. It is the language that is used for describing digital systems like a network switch or microprocessor or a memory or flip-flop. Any digital system that can be described using Verilog HDL. Okay. So that means by using HDL, we can describe any digital hardware at any level. So as a very simple circuitry like any combinational circuit which is having different types of gates that can be described using Verilog language, or at the same time we can go for the memory design, we can go for the microprocessor design. So that can be done using Verilog language, okay, like a VHDL only. So designs which are described in HDL that are independent of the technology, very easy for designing and debugging, and are normally more useful than schematics, and this is particularly for large circuits. Okay? Whenever we are going for the large circuit, that time when we are having certain code for that circuit, then that becomes easier. At the same time, before actual design or before actual implementation, this if we are have simulated that circuitry, then that becomes easier uh, to understand what are the problems that we are going to face after implementation. And as we know that whenever we are going for the IC design, that time there will be a lot of problems. So whatever are the design problems that we can check it at the simulation level only. So for that, these HDLs that are important. Then Verilog supports a design at many levels of abstraction. So as we have seen in VHDL also, that there are different levels of abstraction, and Verilog also supports all these levels of abstraction. But the major three that we have discussed in a VHDL also, that is a behavioral level, then RTL, that is a register transfer level, that means what we say it as a data flow level, and then gate level. Okay, so all these levels of abstraction that are supported by Verilog. So what is meant by behavioral level? Okay, so let us again see this. So this level describes a system by concurrent algorithm. So how this uh, what will be the processes that we are having in the system, that concurrent algorithms we will have in a behavioral level. Every algorithm, that means every process that is present in the behavioral level, that is sequential, which means that it consists of set of instructions that are executed one by one. Okay, so remember that every time the processes or the algorithms that are concurrent in nature, but all the statements in the algorithms that are sequential, that means they will be executed one by one. Then functions, tasks and blocks, that are the main elements in the behavioral level. There is no regard of the structural realization of the design. So here, what will be the structure of the system that we are not getting in a behavioral level? We just know about what will be the behavior of the system in a behavioral level. So that means whatever is the behavioral of the system, what is the truth table of the system, depending on that we have the behavioral level of abstraction. Another level, that is a register transfer level, that is a RTL. So this design using the register transfer level specifies the characteristic of the circuit using operation and the transfer of data between the registers. So that means this is the data flow modeling actually. Okay. So here all the designs that are defined using the operations that are performed in that system, and how the data is transferred from one register to the another register. Depending on that, it is modern. Okay? So the modern definition of RTL code, that is any code that is synthesizable, that is called as a RTL code. So whatever code, if it is synthesizable, then we call it as a RTL code. One more level of abstraction, that is the gate level. So in that, uh, within this logical level, the characteristic of a system that is described by logical links and their timing properties. So all the signals, as we know that they are discrete signals, so they can only have definite values like 0, 1, X or Z. That means don't care and all. So the usable operations that are predefined logic primitives. Okay? So that means basic gates that we have. So all these operations that are predefined logic, and the gate level modeling, that may not be a right idea for logic design. So whenever we are going for the designing certain logic, so for that this may not be good uh, level of abstraction, but otherwise gate level code is generated using tools like synthesis tool and his netlist, which is used for gate level simulation and for backend. Okay. So this is about the level of abstraction that is supported by Verilog HDL. Okay. So now let us see what is difference between the Verilog and HDL. Okay. So actually, I just found this very interesting figure or picture that on internet. So I have used this. So let us first see. There is a match between Verilog and VHDL. Okay. So what is VHDL? Sorry. First of all, we will see Verilog HDL. So it has the characteristics like it has very good acceptance in ASIC, particularly for lower level designs. Okay. So register level transport and below, for that this Verilog HDL is very good. Then it results in fast simulation. So that is one advantage of Verilog over VHDL. So it results in a fast simulation, and it has relatively simple, easy in first contact. So as compared to VHDL, it is relatively simple, and those who know about C language, for them it is easier. Okay, more easier, because Verilog, that is based on C language. So those who know C language, this Verilog language is very much easier for them. And in a long term, it might have problem with handling system designs, but otherwise, this is easier as compared to VHDL. But one more thing is that Verilog is a case sensitive. Okay, that means we have to take proper care regarding in which case we are writing code. Okay, so all the keywords in a Verilog that are in a lower case, and otherwise whatever variables or identifiers that you are going to specify, you can have it in any case, but you have to take care about this, that Verilog is a case sensitive. Okay. Now this Verilog is mostly used in North America and Asia, Japan, and especially among industrial supporters. Okay, so mostly all the supporter in industrial supporters that are using Verilog. Okay, but this language is not popular in Europe. But if you see in India, Verilog is the preferred HDL. Okay, so this is the language that is used in most of the VLSI companies. Okay, then now let us see what are the characteristics of VHDL. So if we go for the comparison in between the how it behaves for the lower level design, then as compared to Verilog, this is relatively weaker, but it is superior in higher and system level design. So where Verilog is a weaker in that case for the system level designs, but VHDL is a superior in that case. Also, one more disadvantage of VHDL, that is it results in slower simulation, but it is constantly improving. So there is a modifications that are going on, and that is why it is constantly improving in that case. It is a very flexible language. Okay, so that is one advantage of this language, is that it is very flexible. It is not a case sensitive. You can write your code in any case. So that is the one advantage of this language. But also it is difficult also to understand, because there are so many statements, so many concepts that are related with this, and that is why it becomes difficult. Also, it is based on Pascal language. Okay, most of you must have not heard this word also, or you may not be aware of this language, and that is why it becomes a little bit difficult to understand. But uh, there are some complex characters that are present in this uh, language. Then it is advantage of this language is that it is very popular in academia. Okay, all the institutions that are using VHDL as a hardware description language for VLSI design subject. Okay, so you can see in most of your syllabus, you will find VHDL as the preferred language for hardware design. Then uh, here lots of skills they were taught by the special forces officers, ADF. As you know that this was uh, designed, VHDL was designed by special forces only, so there are more skills that are designed by them. And many believe that in long term present, better conditions and adaptability than its competitors. Okay, so that means many of users, they are believing that this may be the most preferred language than that of Verilog language. But nowadays, this Verilog is the preferred language in industry. So if you have good knowledge of this language, then you may definitely get job in good core industries. Okay, because there is a lot of demand for design engineers, verification engineers, companies, core companies like Intel, then uh, Sankal Semiconductors, they are also demanding for, which is the Indian company. So they are also demanding for the verification engineers as well as system engineers. So for if you have knowledge, you may definitely get good jobs in this industry. Okay. Now, if we look for the fan club for this uh, wages, then it is especially in Europe. Okay. Uh, because they are using this language very much. But significant number also is in a US and Canada. But this language is disliked in Japan, but gaining popularity worldwide. So this is the difference between the Verilog and VHDL. Okay, so as we know that right now, as industry is preferring Verilog language, so we are going to learn about this language. So now let us discuss about some of the concepts that are present in Verilog language. Okay. So first of all, let us see lexical token. That means the key words that are used in a Verilog language. Okay. So Verilog language source text files are a stream of lexical tokens. That means there are certain, in a Verilog language text file, there are certain keywords that are used. A token consists of one or more characters, and each single character is is in a exactly one token. Okay. The basic lexical tokens used by the Verilog HDL are similar to those in a C programming language. Verilog is a case sensitive and all the keywords are in lowercase. Okay. So always remember that this is a very important sentence, that Verilog is case sensitive. Okay. And all the keywords are in lowercase. So whenever you are going to write VHDL code, you have to take care properly. Then only you will get good results. Okay. Error free results. So let us say now lexical token, that is a white space. Okay. So these white spaces that can contain characters for spaces, then tabs, then new lines and form fields. These characters are ignored except when they serve to separate tokens. Okay. That means whatever is the free space, okay, that is has a one specific name, that is a white space. Okay. So all the spaces, then if you are giving the tabs, then new lines and form fields, all these will be considered as a white spaces. White space characters are blank space, as I said, then tabs, then carriage returns, new line and form fields. Okay. So one more, that is a comment. Now how we are giving the comment in a Verilog language? There are two forms to represent the comment. First is the single line comment that begins with the token, that is a slash, okay, double slash, and end with the carriage return. That means here for example you can see that this is a double slash and this is a single line syntax. Okay, whatever is the syntax that will be written. So this two slashes that will indicate that this is a comment. Okay, so that will be ignored by the simulator. And if you want to have multiple line comments, okay, so that means you are not going to complete your comment in a one sentence and you need multiple line comments. So that time you can have a token like a slash star and then whatever is the whatever comments you want to write there, and after that again finishing star and then slash. Okay, so this is the way to represent comment in a Verilog language. So for example, suppose here slash then star and then you can have any number of line comments that could be written over here, and after that again finishing with a star and slash. Okay, so this is the way to give the comments in a Verilog language. Then let us see how we represent numbers in a Verilog language. So here you can specify a number in a binary, octal, decimal or hexadecimal format. Okay, so in any format you can represent a number. Then negative numbers that are represented in a 2's complement number. Okay, so all these negative numbers that are present in a 2's complement form. Verilog also allows integers, then real numbers, signed and unsigned numbers. Okay, and then syntax for this is given as a this triangular bracket, that is in with that size, then radix and the value. Okay, so this is the syntax to represent the number. Okay, size or unsized number can be defined in a again triangular bracket, then here there will be a size of this present and radix. Okay, that defines whether it is a binary, octal, hexadecimal or decimal number. So that will be radix will represent what type of number it is. Okay, so this is how we are going to represent numbers in a Verilog language. Now after that, identifiers. Okay, so let's how these identifiers that are represented in a Verilog language, that we will say. So what is mean by identifier? Okay, so that is the name which is used to define the object. Now it may be the function or it may be the module or it may be register. Okay, whatever is the name given to all these objects, that is called as a identifier. Now this identifier that should begin with an alphabetical character or underscore character. Okay, so this uh, name for this object that is given like a underscore z, okay, or it could be written in a small lowercase also, that is a underscore z, or it could start with a underscore also. So you can represent it in any of these ways. So that means here we have the identifiers that are combination of alphabetic, then numeric, underscore, and this dollar character. Okay, so these could be used while naming the any function, module, or register. They can be up to 1024 characters long. So that means this could be the length of the name of that identifier. Okay, so there's many characters that could be present in the name for the identifier. And then let us see what are the different operators that are used in a Verilog language. Okay, so in a Verilog we have operators that are special characters which is used to put condition or to operate the variable. Okay. So suppose that we want to take a decision related with the condition, then that time we need to have certain operator. Or suppose we want to do certain arithmetic operation or any numerical operation, in that case also we need operator. Okay, so there are one, two, and sometimes three characters that could be used to perform operations on variables. So for example, we can have greater than, less than, or greater than, plus, then tilde. Uh, so all these operators that are present in the Verilog language. So there are so more operators that are present. So that we will see in the afterwards. Then the keywords that are used in a Verilog. Okay. So these words that have special meaning in a Verilog that are called as a Verilog keywords. Okay, in any language, the word which has certain special meaning, we call that word as a keyword in that language. Okay, so for example, here in this Verilog language, a sign, that is the keyword, then case, while, wire, reg, and or, NAND, and module. All these are the keywords. They should not be used as an identifier. Okay, so you have to remember that all these keywords that cannot be used as an identifier name. Okay, as these are the keywords and they have special meaning, they have particular meaning in a Verilog language. So Verilog language, Verilog keywords also include compiler directives besides all these keywords that I discussed earlier. There are certain keywords which are related with the compiler directive, then system tasks and functions. Okay, so related with that, there are some more keywords that are present in a Verilog language. Okay, so okay. So here for today, we will limit our discussion till this Verilog basics related with this Verilog language. Okay. In the next unit, next lecture, we are going to discuss more details about Verilog language. Okay. So I will be sharing all these PPTs today with you so that you can write it today itself, and then we will start with the actual how we are using this Verilog for writing the code for different combinational circuits. Okay. So is there any doubt about this?
No, ma'am, no any doubt.
Shilpa, Nikhil, hello Nikhil Bhosle.